In our first example, we have a projectile that is fired vertically with an initial velocity of 200 meters per second. It moves up, and then at the very top point, actually we can guess the velocity, right? The velocity will be equal to 0 at the top point. Vt, let's say, will be equal to 0 meters per second at the top. And we are asked to find the maximum altitude of h, where it will have this 0 velocity, and the time t from firing to the return to the ground. So starting from this initial condition to the final condition, what will be the time in this total motion of this projectile. And we are given that the gravitational acceleration is 9.81 meters per second squared. Now, in this question, as we are not given any information about air drag, that means we are not going to use air drag. But in the next part of this example question, we will also consider the air drag. So there is no other type of force that is going to be acting on this particle. But what we know is that there is an gravitational acceleration, and it will be acting on this particle while moving down in the downward direction and while moving down again in the downward direction. So that as it has an initial velocity of 200 meters per second, this velocity will drop to 0, and from this point on, as its top point velocity is 0 meters per second, it will accelerate in the same direction because the motion is in the same direction now, and then it will accelerate and come to a speed. Actually, we can guess the speed because there is no other acceleration on the system. So it will be again 200 meters per second. Actually, we can also calculate if it's going to be that 200 meters per second or not, but since there are no other external factors here, we'll start with 200 meters per second in the upward direction, and then we'll reach the ground with 200 meters per second in the downward direction. Now, what we know so far in this equation, in this example, is that we know the initial speed and we know the top point speed, which is 0. And we are trying to find the maximum altitude. If we consider the initial altitude as h0 to be equal to 0, then h will be with respect to the 0 value. And we can use the third equation here without the inclusion of time, as velocity drops from 200 meters per second to 0 meters per second. What will be the acceleration? What will be the height from 0 height to the h height, which we are looking for? So we can make use of the third equation, which was v dv equals to a ds, but in this case we are using this h. Maybe we can use h here. S is to use, but up to you. And then we can do the integration of both sides from v0 to v, and this is going to be integration of a dh from h0 to h. We say h0 is 0, and then the top velocity is also equal to 0, and if we rewrite this equation, then it would be v squared over 2 from v0 to 0, that is equal to a h from 0 to h, or we could have said s actually, but at the end this is going to be only a h, and we're going to have v 0 squared over 2 with a negative sign and then a 0, that is equal to a h, and here a is an acceleration in the opposite direction of motion, so we're going to have a negative 9.81 as a result of that, and both sides of the equation are negative, so we can cancel out the negatives, and as a result of that we're going to have this equation as 200 squared over 2. Over 2 can be moved onto the right hand side of the equation. 2 times 9.81 h, basically the same equation that we have over here, and then as a result of that we will be able to calculate the maximum height that this projectile will reach. Now for the total time, I said that we already know that it's going to land on the ground with 200 meters per second. This is in the, if we call this as the positive direction and this is the negative direction, that means its initial velocity is 200 meters per second, v initial, and v final would be negative 200 meters per second. Now, based on that, we can use our first equation, as we have this acceleration as a constant, right? And acceleration is equal to dv over dt. And from here, we can calculate a dt equals to dv and take the integral of both sides. Now, we are looking for time here. A is already the same acceleration throughout the motion. It's in the negative direction, right? Negative 9.81 of the positive selected direction. And here we have from 200 meters per second to negative 200 meters per second. And as a result of that, the initial time is 0, the final time is t, let's say, and as a result of that we're going to have negative 9.81 times t, that is equal to negative 200 minus 200, and from here we can do the calculation for t, and that's basically the result that we already have in the lecture notes. So, here we have the solution as 40.8 seconds, and that's our solution for this basic example. Now we're gonna add the fact that you actually have air drag in such cases, and as a result of the air drag, what we expect is that as this projectile is going up, there will be a resistance of the air drag. It will be in the downward direction, so let's call it a d. And while going down, there will be again resistance, but now the velocity is in the downward direction, so the resistance of the air drag will be in the opposite direction. So the total acceleration that this projectile will experience while going up and down will be different. So in the next part of this question, we are going to deal with the problem of air drag. And air drag will be a function of the